Hi there, welcome to my course, Water Resource Engineering. So I am Sabara Binti Musa from Faculty of Civil Engineering and Built Environment. Assalamualaikum warahmatullahi wabarakatuh. We continue our chapter 4 about part 2 for water structure. So for this part 2 about the component of dam and reservoir. Okay, the learning objective for this topic to identify the hydraulic structure of the dam and to design one part of the principal structure. The component of the dam and reservoir, they have a structure, hydraulic structure used for constant flow of pressure, and hydraulic structure used for flow in per channel with no pressure. So the dam and the reservoir release through the two principal type of structure. So this is a sluice gate. So sluice gate is have a pressure, and this is a type of weir. This is no pressure here. So this is open space. So this is a constant pressure and no pressure here. So this is a two principal type of reservoir and dam. Okay, we consider about the type of dam. Usually, the different type of the dam based on the hydraulic design, type based on the various function, based on the material of construction, based on the structure, and based on material. Okay, for this component of the dam, there are different kind of a dam. Okay, so this is a dam generally has an upstream slope and downstream slope. So they have both have a different section. So this is a cross section for structure of dam. So this is a crease, spillway, sluice way, and there's some gallery here too. So this is a water level of the dam. Okay, component of dam is a crease. Crease here to parapet wall, gallery, spillway. This is very important for this the dam. So spillway they has a control and uncontrolled, freeboard, the storage level, diversion tunnel. So for the two principle of the dam, so we have focused on the spillway. So for this part, the spillway provide for water storage and station them to the release surplus water or flood water. Okay, spillway have outlet work, and we call as a conduit. So the outlet work like the sluice gate. This is a sluice gate, and then the conduit it is like this. The true embankment dam. Okay, and then the energy dissipated. This is very important to release for the release pressure. So this is energy dissipator was designed to dissipate excess energy. So this is high velocity here. So this is energy dissipator. This is area of energy dissipator after the flow wall. Okay. So for this topic, we can design for this energy dissipator for this dam. Okay. Now we go through the spillway. Okay, what is the spillway? Spillway is built in a reservoir to allow the flow of water safely move downstream when the reservoir is full. So the spillway capacity must accommodate the maximum design flood. Okay. Some spillway are shaped as a rectangular concrete. So a design that connect to the upstream and downstream region of weir. Okay, actually spillway is located at the top of reservoir hole. So they have a bottom outlet with a valve or gate which may be operated to release the flood flow. Okay, so this is some spillway. This is spillway. So spillway at the top of the dam. So this is some cross section. Spillway. This is a control spillway. Cutaway cross section of the spillway. This is example. So this is hydraulic jump occur here, and then this is Stanley basin. This is Stanley basin of tailwater. Okay, different bay, and then spillway crease and flow. Okay, for this spillway, the two main type spillway is based on the controlled and uncontrolled spillway. So, controlled spillway by mechanical structure or gates. So, but the uncontrolled spillway, no gate. So, they have no gate. So, this is based on the control by the release based on the overflow. Overflow. So, the best design is based on the requirement of type of dam. Okay, this is example for spillway. Okay, this is OG spillway. So OG spillway type. So this is an equation for each type, and then the spillway shape based on the shape. The equation based on the shape of the spillway. Okay, so the second is energy dissipator. For this structure, water flow in the high flow. So when the water flow in the high flow, spillway produce a high kinetic value. So based on this design, the energy dissipator can decrease the energy, and reduce the damage at the toe. So this is very important. To convert supercritical flow to subcritical flow. Okay, this is example. The very simple energy dissipator structure. Water from here, and then the falling, and then this is definition, some information about the dissipator. Okay, this is a energy dissipator structure at the toe of the outside of the dam. Okay, so waterfall here, and then they release for this energy here. Okay, so the types of this energy dissipator we call as Stanley basin type 3. Type 3. So they have three structure here. So this we call it the Stanley basin type 3. Okay, this is equation we need to use for the design of the Stanley basin. So for block A, this is block A, the row of the block A. We use this equation for block B at the middle. This is on block B, and then block C at the end of the structure. So we have a design for this block, and then calculate the length and the size of this structure for this Stanley basin. Okay, this is equation we use for the Stanley basin. This is a basic y and velocity each y. So we need calculate the parameter y, l, and etc. Okay, this is a graph value for frac number. So we can use for this plotted a graph to identify the value for the L of Y2. And then, okay, this is a step, a very simple step of the design Stelly Basic. First, identify velocity, y, and prime number. And then second, determine the L value, length of the structure. And then identify block A, block B, and block C. Finally, we can sketch the design of the structure. So this is an exercise you can try yourself. This exercise for this design for Stelly Basic. Identify, follow this step, try again, and identify each block size, and then finally sketch for this equation like this, and then you can dimension for each side, for the S1, W1, the size, dimension of each block, and then the value. So finally you can use this sketch, how many block for this row, for block B how many block, and block C. So you can sketch and put the actual value for this dimension. Okay, thank you.